denote? How would they label the beginning of the road? What station would the beginning of the road be? 0 plus 0, 0. So how many feet is this area, this station right here, reference to the beginning of the road? 1,000 feet. So the road is always labeled from one point to another. So in this case, we're only seeing a section of the road, and the section that we're seeing is from 10 plus 0, 0 to 13 plus 0, 0. So what's the total length of the road you're seeing? 300 feet. 300 feet. Okay, so what's happening to the road? Is it going down? Is it going up as it goes from 10 plus 0, 0 to 13 plus 0, 0? Can you tell? Okay, so instead of answering that, let's look at this first.
I think it's coming down.
Okay, so let's look at this right here. Where's the road? The road's here, right? This is the road, and this is the center line of the road. So what are these things called on the sides? Embankments. We know that word already, right? Embankments. And when we describe embankments, what that has a slope, do we use percent grade? Do we use vertical angle? Or do we use the H to V? H to V. For embankments, we use H to V. So where is the road reference to what the existing ground is? Looking here. The road is here, right? Where's the existing ground surface? Below it. How do you know that? There's a stake in the ground, right? You can't suspend a stake up here. A stake is always put in the ground at the existing ground surface. So here's the existing ground surface. What are we going to do to be able to put the road higher? Fill it. Remember we talked about cut and fill way back in the semester? And sure enough, it says there's a fill slope. Okay, we're not going to talk about the intercept. So here's our road. Here's the existing ground surface. So we had to put soil in. We had to bring soil into the site to raise the road. Okay, now let's go up to 13 plus 0, 0. What's happening there? What was that? They're removing material. So where is the stake in the ground now? Is it higher or lower than the road? It's higher. So the existing ground surface is high, and the road, where the road's going to be, is lower. So what do they need to do? They're not going to fill it. Instead, they're going to cut it. Okay. So in the front, at station 10 plus 0, 0, the contractors have to bring soil in. And over here, they have to remove soil. So when you haul soil in, do you have to pay for the soil? Yes. Do you have to pay for the hauling charge of the soil? Not just the material, you have to pay for the hauling charge. Okay, if you want to cut soil, do you need to hire someone to cut it? Do you have to get rid of it? Yes. And do you have to pay to haul it away? Yes, and pay to dump it. So what do you want to do on a job site? Minimize cut and fill. You want to make sure that if you're taking soil away here, you fill it over here. Okay, if you need soil here, so it's all a balancing act, because you want to come pretty close to 0. You don't want to move it. And you don't want to move it great distances either, right? I don't want to take soil from station 10 plus 0, 0 and then have to move it to station 100 plus 0, 0, because that's another hauling charge. But it still saved me from dumping the soil somewhere. You always have to prove that the soil is clean before you get to dump it. If it's contaminated, if it has oil or anything, gasoline in it, you need to actually haul it off to a different site where you're going to pay more because it's considered hazardous now.
Not super important, but if you have a job site where you have to cut in one area and fill in another, are you allowed to take that dirt and use it as fill if it's not like a state job?
You can, even if it's a state job, you can. But let me answer a different question first. do you ever see signs that say free dirt, free fill? Why is somebody giving it away for free? Because they don't have to haul it off, right? So there are plenty times, you know, when I was a geotechnical engineer and I'd be driving around, I'd be looking at dirt and see if there's piles I could get anywhere. But you can't just take dirt from any place because it might have a lot of organic material in it, right? What's the problem with organic material? It decomposes and then you have voids, right? And then you have to compact it or it settles. So you want, and peat is an organic material, that's not good. So you always have to have the geotechnical engineer test the soil to see if it's okay for fill material. So in the case of removing it and putting it, I think you still have to go through that process.
Yeah.
I mean, it could be organic material that you're picking up, it could be, you know, if it's too clay, you might not get the right compaction.
Makes sense.
Okay. So if, in this particular case, I can calculate this area, right? I can calculate that area. Let's just assume we're going to, well, actually, let's talk about it. How do you calculate that area? Okay, one, you could do it by a trapezoid, right? Or you could do it by triangles and squares. What other sophisticated ways do you know in this class to do areas?
Double angle?
The double area method. If I know the coordinate of this point, this point, this point, and this point, can I find that area? Right? And then let's take that area and just multiply it by a 1 foot width. A 1 foot width. Then I have a volume, right? If I calculate the area and multiply it by 1 foot, I now have a volume. When I dig out that soil and I put it on a pile on the side, on the site, is that pile going to have the same volume as the volume that I cut here? It's the same exact soil, but it's not the same volume. Why is it not the same volume?
More aerated.
It's more area, but why? Why is it more
Aerated.
volume? What?
Has more air in it.
Aerated, sorry, it's more aerated. Because right now, this has been here for a long time, right? So we don't really know what was there before, but it probably has been compacted somewhat over time. Rain is going to cause it to get compacted. Maybe, I don't know if a car went over it or whatever. But it's going to be compacted. When you take all that soil out and you put it on a pile, it's not going to be compacted, right? So let's say in your backyard you dig a hole. Right, you dig a hole, dig a hole, dig a hole, and you have this pile. The volume of that pile is going to be bigger than that. Is it going to be easy to get that soil back in that hole? No, you can't just dump it all in because it's going to have this, it's going to be high up. So what do you need to do? Compact it only at the top? No, you have to compact it in lifts. L-I-F-T-S, you're going to compact it in lifts. You're going to take a little bit in, put it in, you know, compact it, put a little bit more in, compact it, put a little more, and eventually you could get all of it back in there. But just realize that when we're dealing with cut and fill, we have to make sure that we're dealing with the same compaction. You know, Jameson, hang on. I didn't even think, it's 7 o'clock. Do you guys want to take a break? We didn't take a break yet. Since you're getting up, do you guys need a break?
I did just the bathroom.
Yeah, well, that's fine. Let's take a break. So just realize that we have to somehow equate the cut and the fill because we need to make sure that something's more. So Strider said aerated. Really, the other one is just more dense, right? When it's already in there, it's been compacted over time. It is dense, but it's looser when it's pulled out. Okay, let's take a 10-minute break.